In example 7, they start to get a little bit harder. So there's going to throw in a bunch of different things all in the same kind of problems to just try and trip you up. So looking at example A, the first thing that I'm going to look at is the top. Looking at the top, you've got just a normal polynomial. You can plug everything in for x. There's not weird fractions. There's not weird square roots. So the top is going to work out just fine for me. But looking at the denominator, there's a couple of things that we need to consider. The first thing that I notice is that I've got a square root. Remember that we said square roots, so x minus 2, square roots have to be greater than or equal to 0, right? Greater than or equal to 0. And we said earlier that in the denominator, square roots couldn't be 0, but because we've got this extra plus 1, if this square root was 0, the denominator would not be 0, the denominator would be 1. So that actually works for this problem. So one of those things that you need to take a look at. So if I'm solving this, I would get that x has to be greater than or equal to 2. Okay, so x has to be greater than or equal to 2. The other thing that we need to consider, though, remember, is anywhere the denominator would equal 0. Okay, so let's consider that. So if the denominator, I'm going to write that over here off to the side. If the denominator were to equal 0, so x minus 2, the square root of that, plus 1, that we know cannot be 0, right? Because if that's 0, then the whole fraction doesn't exist. So if I've got the square root, let's solve this for x. The square root of x minus 2 cannot equal -1 if I subtract that 1 over. Well, consider what this is saying. This says the square root of x minus 2 cannot equal -1. Well, that's a true statement all the time because square roots cannot be negative. You can't take the square root of whatever number this is and get -1. It doesn't work. So this is not a thing that is ever going to happen, so we don't need to worry about that. So that doesn't matter. So the only thing that we need to worry about is that x has to be bigger than or equal to 2. So remember in set notation, or interval notation, excuse me, we would say that it goes from 2 to infinity is the domain of that function. Okay. B is pretty similar. Looking at the top, again, we've got a polynomial, so no weird square roots, no weird fractions, everything's fine, so the top works out. Looking at the denominator, I know that this has to be greater than or equal to 0, okay? So let's consider that first. So x plus 5 has to be greater than or equal to 0, because if this is 0 and we do 0 minus 2, that's not actually 0, so it can be or equal to. If I solve that, I get x has to be greater than or equal to -5. Okay, so x is greater than or equal to -5. Now, let's consider where the denominator would equal 0. So the square root of x plus 5 minus 2 cannot be 0, right? The denominator can't be 0. So I'm going to add the 2. So the square root of x plus 5 cannot be 2. Well, this could be a true statement, so we need to keep solving. So I'm going to square both sides. Okay, so this is going to leave me with x plus 5 cannot be, 2 squared is 4. I'm going to subtract the 5. So x cannot be, 4 minus 5 is -1. So x has to be greater than or equal to -5, but it cannot be -1. Okay, so we're going to start at -5. Our next problem exists at -1, which it cannot be. And then it can be everything from -1 to infinity. So it's got to be greater than or equal to -5, but it cannot be -1. Okay. Taking a look at C. C, we don't have to deal with a fraction, but we do have to deal with the square root, right? So we cannot have something be less than 0 under the square root. So I know, again, x squared minus 4 has to be greater than or equal to 0. Okay? So x squared has to be greater than or equal to 4. Now comes the part that might trip some people up. So make sure you're paying attention to this part pretty intensely. If I have x squared is greater than or equal to 4, everybody knows at this point that you're going to take the square root. Okay, and the square root of x squared is x. But remember, when you take square roots, you get a plus or a minus answer. So this square root of 4 is actually plus or minus 2, okay? Also remember back to a rule with exponents, whenever you change the sign by dividing by -1 or something like that, you have to flip this sign around. That is going to occur when you do the square root as well. So when we take the square root of the 4 and we get the +2, everything stays the same. And that's fine. But when I take the square root of the 4 and it changes to -2, the sign has to switch around. So you couldn't just say x is greater than or equal to plus or minus 2 because that's not accurate. When it changes to -2, the sign switches, okay? So make sure you're aware of that. So take a look at this. I've got x is greater than or equal to 2 and x is less than or equal to -2. So this term is everything from -infinity to -2. And this term is 2 to infinity. So the part in between there, the part between -2 and 2, does not exist. So this function exists from -infinity to -2, which is what this part tells me, union 2 to infinity, which is what this part tells me. So this function exists everywhere except for between -2 and 2. Okay, that's going to happen a bunch, so just be aware of that. Taking a look at D, same thing, no weird fractions, but I do have to deal with the square root. So I need 4 minus x squared to be greater than or equal to 0. Okay, same kind of deal. I'm going to add the x squared over. So 4 is greater than or equal to x squared. Okay, and again, I don't really like the x squared on that side, so I'm going to switch them around. Make sure that the sign is still facing the correct way. So the point is at the x. So point is at the x. 4. Okay, so x squared is less than or equal to 4. Okay. So again, I'm going to take the square root because that's how I solve these. And when I take the square root of 4 and I get plus or minus, the minus answer gets a sign change. So the square root of x squared is x. Keep it the same for the +2. But when I do the -2, it's going to switch around. So now take a look at what this says. This says x has to be less than 2 and x has to be greater than or equal to -2. Well, this one, if it's less than 2 and greater than -2, this one represents only the area between them. So this is going to be -2 to 2. And in writing down the answer for that one, I realized that this one should have had brackets, not parentheses. Because it's or equal to, right? It can actually equal the 2. So make sure you go back and fix that. Okay, these should be brackets, not parentheses. So these are brackets. So this is the area between -2 and 2, whereas this is the area on the outside of the -2 and 2, so the outside of the interval. Okay. Taking a look at letter E. Letter E is back to the ones we've been dealing with, right? So taking a look at the top, you can plug anything into the top and you're totally fine because there's no square roots, there's no weird fractions. Looking at the denominator, I know that this part has to just be greater than 0 because I have the square root by itself. So 3 minus 2t squared has to be greater than 0. Okay, so let's solve it again. 3 is greater than 2t squared. I'm going to flip it around and divide by the 2 at the same time. So normally I would have put the 2t squared over here, but I'm going to call that t squared. The point's facing the t. And I'm going to divide by 2, so this is 3/2. So I divided by the 2 to get 3/2. But then I flipped it around because I want my t on this side. And that's just a personal preference. If it doesn't bother you to have the t on the right, leave the t on the right. That's okay. So t squared is less than 3/2. So again, square root, I get t. But when I square root the 3/2, the positive version keeps the sign. And the negative version gets a sign change. Okay? And yeah, I know the answer that it's the positive square root of 3/2 and the negative square root of 3/2 is kind of a gross answer. And do I really know exactly off the top of my head what that square root is? No, but I don't really care because we're just talking about domain being an issue at this number, whatever it might happen to be. So I get that t is less than this and greater than this one. So it's again the area in between. But it's not or equal to because it's the denominator without any sort of addition or subtraction, right? So this is the area between. So this is negative square root of 3/2 to positive square root of 3/2. Because it's the area between, okay? And looking at F is a doozy, okay? F has a lot of issues. The first issue that I notice with f in looking at the top is it's got a denominator in the top. So on the top, I know that n cannot be 0. Because if n is 0, then this piece of the top doesn't exist, which makes the whole fraction not exist. If you look, that same thing happens in the denominator, okay? So that's my only issue on the top, and it's one of the issues I have on the bottom. Because the bottom as a whole, the n minus 1 over n, we know can't be 0 because it's the bottom of a fraction, right? So n minus 1 over n cannot be 0. Okay, well, if I have n minus 1 over n, if I multiply the n over, now I just have n minus 1 cannot be 0 because 0 times n is still 0. So if I add 1, I know that n cannot be 1. So now I know that n can't be 0 and n can't be 1. So I'm going to go from negative infinity to 0, where I have my first issue. And then I'm going to go from 0 to 1, where I have my next issue. And then I'm going to go from 1 to infinity, because the rest of the function exists. Okay? And it asks you to verify on your calculator. If you want to type this into the calculator and check and make sure that that's where the function doesn't exist, please feel free to do that.